To summarize what we know about the situation where the ball rolls down the ramp and off the edge and down to the floor as a projectile from this point to this point down to the floor, during the uniform acceleration phase of the motion, the uniform acceleration phase starts when the ball leaves the ramp and ends at the instant the ball hits the floor. So from the instant the ball leaves the ramp to the instant the ball hits the floor, it is accelerating uniformly downward at 9.8 meters per second squared, zero acceleration in the horizontal direction. If the ball falls at distance delta y, then by making measurements on the ramp or assumptions about the way the ball goes down the ramp, we can determine the initial velocity of the ball in the horizontal direction, assuming the ramp projects the ball at a horizontal. And then if we know delta h, we could of course calculate the delta t that would be expected, and from v0 we could calculate the delta x. Alternatively, if we observe the delta x, we should be able to calculate the v0 and correlate that either with the theoretical initial velocity resulting from the fall delta y, or from some sort of measurements we might make on the ball as it goes down the ramp. Now the proportionality situation is that if, well, first of all, if we observe that v0 is proportional to the square root of delta y, and this does seem to be the case, and if delta x is also proportional to delta y, then if delta t is in fact the same for all objects going off the edge of the ramp, then we establish that fairly easily by flicking an object horizontally off the edge of the ramp at the same instant we drop the object. It doesn't matter how hard we flick it, as long as it starts out horizontal. The two objects, the one that's dropped and the one that follows the projectile path, will hit the ground or the floor at the same time, again assuming a level floor. And this tells us that delta t does seem to be the same for all cases. In that case, v0 is going to be, well, got a little ahead of myself. From these two facts, v0 is proportional to delta x. Now, if delta t is the same for every v0, then the delta x is going to simply be the average x velocity times delta t, and the proportionality constant here is going to simply be the average x velocity. And in that case, the average x velocity is going to be simply delta x over the delta t that we find. Since the object, by assumption here, is not falling far enough to get up enough speed for air resistance to be a factor, we can fairly easily calculate delta t from the distance the object falls. Now, if Vx is constant, then V0 will equal the average x velocity, which is delta x over delta t. If, in making comparisons, we find that the V0 observed here by this assumption is the same as the V0 that we find either by observing the object going down the ramp or by theoretically calculating what the V0 ought to be from a given delta y in a given situation, then we have good evidence, perhaps even proof, that the horizontal velocity is indeed constant. And that's what this whole thing is all about.